Comparing values from different data sets. This is another special situation where we've got several different data sets and we want to compare them. But if a data set has different means and different standard deviations, then we can't just compare those pieces of data without doing some work first. So what we have to do is, number one, for each data value, we have to calculate how many standard deviations away from its mean the value is. Then we need to use this formula that we've used before, value equals mean plus number of standard deviations times the standard deviation, and we need to manipulate it so that we get this formula here, which is number of standard deviations equals the data value minus the mean divided by the standard deviation. Once we've done that, we can compare the results of these two different data sets. Number of standard deviations in statistics is often called a z-score, and we use the symbol z, and we will use this in other parts of this class, so this is something that you will want to understand and know how to do. So last, down here we have a table with sample, and it shows us the sample and the population the way that we would write how to find the z-score. Next, I want to show you how to do two example problems calculating this value. Okay, let's take a look at this first problem. It says two students, John and Al, from different high schools wanted to find out who had the highest GPA when compared to a school. Which student has the highest GPA when compared to a school? So you can see here that John and Al's schools use two different ways to calculate GPAs. And they want to compare them and figure out who has the highest or the best GPA. And so in order to do this, we need to find the z-score and compare the z-scores. So let's go ahead and get started doing that. So if you recall, the z-score, and this is a sample, is going to be the data value minus the mean divided by the standard deviation. So first we'll calculate John, and his data value is 2.85 minus the mean GPA for his school is 3.0 divided by the 0.7 standard deviation. So we'll enter this into our calculator, and we get, and please be aware of your positive and negatives, we get negative 0.21. Now let's take a look at Al. Al has 77, and the mean GPA is 80. Standard deviation is 10. Negative 0.3. So what this means is that John is 0.21 standard deviations below his school's mean, while Al is 0.3 standard deviations below his school's mean. So GPA, the idea is you want the highest GPA. So in this case, John has the highest GPA compared to his school. So now let's take a look at another problem down here. So two swimmers, Angie and Beth from different teams, wanted to find out who had the fastest time for the 50-meter freestyle when compared to her team. Which swimmer had the fastest time when compared to her team? So if you want to, you can pause the video and try to solve this on your own and then come back and play the end to check your answers. So we are going to do the same thing that we did before, which we know that the z-score is the data value minus the mean divided by the standard deviation. So we have Angie, and her time was 26.2. The team mean time was 27.2. and her team's standard deviation was 0.8. So we get an answer of negative 1.25. And then we're going to calculate for Beth. Her time was 27.3 minus 30.1 divided by 1.4. So what this means is Angie is 1.25 standard deviations below her team's mean time, while Beth is 2 standard deviations below her team's mean time. Now, this is different from the problem above, because in swimming, you want to get the fastest time, and the fastest time is the shortest time, or the smallest time. So when you think about Beth and Angie, Beth is farther in the negative, so she is farther away from her team's mean time than Angie is, which means that Beth is actually faster, and she is the fastest of the two. So be careful, you have to think about each scenario and think about what the goal is. So just make sure you're reading the problems completely and understanding everything fully. The last thing we are going to cover in this chapter is Chebyshev's rule and the empirical rule. So Chebyshev's rule is for any data set. It doesn't matter what the distribution of the data is or looks like. And it says that at least 75% of the data is within 2 standard deviations of the mean. 89% of the data is within 3 standard deviations of the mean, and 95% of the data, that's almost all of the data, is within 4.5 standard deviations of the mean. Now, when you have a distribution that is bell-shaped and symmetric, okay, bell-shaped and symmetric, that's very important, then this is known as the empirical rule, and what it says is that approximately 68% of the data is within 1 standard deviation of the mean. 95% of the data is within 2 standard deviations of the mean, and 99% of the data is within 3 standard deviations of the mean. So keeping these rules handy can be helpful as you are analyzing the data in our class.